example number 2 is going to resemble example number 1 in all areas except we have a different parent function. So let's start by, if you prefer, we can rewrite this as log base 1/3 of x, and we can put y on the opposite side. They're the exact same function. But the next thing we need to do is we need to rewrite it in exponential form. So the base is 1/3. I'm going to raise it to the power of y, and I end up with an answer of x. Now I'm going to make my little t-chart here. I think personally if we have 3 ordered pairs, we're good to go. So let's start here with 0. If I put 0 in, what is 1/3 to the 0? Well, any value to the 0 is 1. Let's put in 1. 1/3 to the 1. Well, 1 to the 1 power is 1, and 3 to the 1 power is 3. By the way, just so we can graph this, 1/3 is approximately what as a decimal? 0.33 repeating, right? So I'm just going to come off to the side here because we're just estimating and write 0.3 repeating, just so we get an idea. Now, if I square this, so if I had a 2 here, 1 squared is 1, and 3 squared is 9. Now, on my calculator, I'm going to show you that 1 divided by 9 is approximately 0.1 repeating. So this is approximately 0.1 repeating. Okay, you ready to graph this? Here we go. This is our parent function. So we're still going to go to that y-axis, and we're going to illustrate that the vertical asymptote is still x equals 0 for this logarithmic function. There is no horizontal or vertical shifts, so I'm going to go 1 to the right, and here's 1, 0. Now, it's really hard to approximate this, right? I get that. I'm going to go 1/3, so 1/3 and up 1, and I'm going to go 1/9 and up 2. And we can see the general shape here. It's getting already closer and closer to the vertical asymptote, but it's never actually going to touch it. So that was part A. Part A was let's come up with that parent function. So I can see that the parent function is log of 1/3. The first thing I'm going to write down is I'm going to write down this basic 1, 0, 1/3 1, and 1/9 2. My goal is to accurately sketch it. Where do I start after I write down the ordered pairs? I start by recognizing there's a shift. Do I go to the right 2 or left 2? Right 2. So now my vertical asymptote has shifted to the right 2. The vertical asymptote has shifted to the right 2. So vertical asymptote is now x equals 2. Taking care of that. I'm going to shift everything up 5. 1, 2, 3, 4, 5. This is like my new origin. Done. I have one thing left to do. Turn to your partner because it's so easy to get mixed up here. Does this negative sign out front that's hiding, does it get multiplied by the y's or the x's? It's the y's. Draw a little arrow to the y's. Well, 0 times a negative doesn't change anything, but it does become -1 and -2. So from this position, I'm going to go 1, 0. So I'm going to move over 1, 1, 0. Done. Then I'm going to move over 1/3, which is really hard to do, and I'm going to go down 1. And I'm going to move over 1/9, which is barely anything over, and I'm going to go down 2. And we can see this time it's headed down and getting closer and closer to that vertical asymptote, but it's never touching it. So where do I even start with this? Because it can absolutely seem overwhelming. The first thing I do is I recognize that we're working with the parent function log of 1/3. So I'm going to start right away by writing down 1, 0, 1/3 1, and 1/9 2. By raise of hand so I can see where you are. How many people did that as well? You wrote down the parent function. Awesome. Okay, next I look up here and I'm like, uh-oh, this doesn't look right. That x has to be by itself. That means I need to factor out that -2. So -2 times x is -2x. I need a positive 4. -2 times -2 is a positive 4. Okay, time to graph here. I'm shifting this to the right 2. This is a very difficult problem. And just so I can see, for those that are live with me, how many of you actually shifted the vertical asymptote to the right 2? Wow, about half of us, that's hard to do. Okay, got that? And now I'm shifting it down 1. So this is my new origin. I've got one thing left. This gets multiplied by the, anybody remember? X's. Oh, this is tough. So I'm taking negative 2 times 1. Okay, that's negative 2. I'm taking negative 2 times 1/3. That's negative 2/3. Negative 2 times 1/9 is negative 2/9. Okay, so from here, I'm going to go left 2 and stay. Left 2 and stay. Then I'm going to go left 2/3. It's approximation. And I'm going to go up 1/3. Then I'm going to go even less amount and up 1/9. Oh, sorry. I'm going to go less amount and I'm going to go up. Let's do this into approximations. Did I write something down wrong? I hope not. This is about negative 0.6 repeating, and this should be 0.2 repeating, negative 0.2. Okay, 0, negative 2. I like that. And then I go over 1. Okay, and I'm going to go up 0.6. Okay, got it. Then I'm going to go over. Do you guys see my mistake I made? Do you guys see my mistake? What am I getting mixed up here with? I feel confident that I put down the math right, but I don't feel confident in what I just graphed. Let me try this again. I'm going to go left 2 and stay. Agree. I'm going to go left 0.6 and up 1. There it is. I'm going to go left 0.2 and up 2. There I go. Okay, so it's coming in like this. Sorry about the graphing there. That are in the classroom, I've asked them to come up with the ordered pairs. So if you want to, you can rewrite this as such. So it looks like this. And then I have the base of 3/2 raised to the y equals x. So how do I come up with these values? So I'm going to start with plugging in 0. So 3/2 to the 0 is 1, because anything to the 0 power is 1. Let's plug in 1. 3/2 to the first power is itself. By the way, 3/2, just so you know, is like a 1.5. Now, if I square this, 3 squared is 9, and 2 squared is 4. And we could grab that calculator and look at that. 9/4 is approximately 2.25. Bless you. With that information, you have one final problem. You're going to take this like a test question. Are you ready? You have this. Bless you. Here is your problem. Please graph this function. Those that are working in my classroom still have another 2 minutes left, but this is the problem that I challenge them to do. Now they're going to use this ordered pair above. This is the ordered pair that corresponds to the parent function that we're working with. So when I look at this, I need to be aware of the 2 up front, and I need to be aware that inside I need to factor out that -1. -1 times x, that works. -1 times -1 achieves a +1. So if I'm graphing this, I want to shift that vertical asymptote to the right one. How many of people that are live with me, although you may not be done, by raise of hands, shifted the vertical asymptote to the right one? Hands up high. Okay. So my vertical asymptote is x equals 1. Done. Now I'm going to find the origin 3 below. 1, 2, 3. This is my origin. I'm going to write down that ordered pair that you see up above. And this comes from the parent function. I could put 3/2, but I know it's 1.5. It kind of helps me out. I could put 9/4, but I think I'll put down 2.25 because it just kind of helps me out. Okay. When I see this negative sign, I'm going to multiply it by the x's. Whatever's in front and factor it out multiplies by the x's. So this becomes -1, -1.5, and -2.25. Or I could have left them in an equivalent fraction form. The 2 is going to be multiplied by the y's, anything stuck in front. So 0 times 2 is still 0, but multiplied times 2 and multiplied times 2. So I'm ready. From here, I'm going to go left 1 and stay. Then I'm going to go left 1.5, so left 1.5 and up 2, and left 2.25. So here's 2, 2.25, and I'm going to go up 4. And we can see it's getting closer and closer as it goes like this.